Hi, this is Mark Kemper with EMS, and in this video we're going to talk about the different rapid prototyping technologies available on the market and what the advantages and disadvantages are to each one of those. Now at EMS we offer all the major rapid prototyping technologies that are out on the market today, and what we do is we try to sit down with a customer and really find out what their application is, meaning how they want to use the prototype, what their budget is, what their time frame is, maybe the quantity, and really try to dial it in and fine-tune what's the right technology for their needs. Because there's a lot of technologies, there's a lot of different materials. And these cell phone covers here represent the major technologies and the major materials. And what we'll do is we'll go through all of these and really kind of talk about what the advantages and disadvantages are to each one of those technologies. So let's go ahead and get started. What you see here on the table is a pretty good representation of all the different major rapid prototyping technologies available on the market, with some of the more popular material choices for each one. Let's start over here on the left. This is stereolithography. Stereolithography's been around the longest. It's been around really since the mid-'80s. And the way stereolithography works is it uses a laser to cure a vat of photocurable resin. And again, if you want to learn more about any of these technologies or see videos on how they work, go out on the internet, YouTube, Google, any of these terms, and you'll see a lot of videos on how they work. But what SLA brings to the table is a very good surface finish, very good detail, because the layer thickness can be low as 1/1000th of an inch. So if you really want a high, what we call appearance model, something you may want to paint or chrome plate, SLA is very good for that kind of stuff. Tends to be more expensive than other processes, but you get a very good model. The other advantage to SLA is the ability to do clear parts. So you can see this is a clear part in one of their materials. So if you ever need something see-through or basically to imitate clear plastic, this is a good choice. Here's one that's more translucent, so kind of semi-clear. Now, SLA materials are good for appearance, but not the best for strength. High heat can warp them, and they tend to bend a little bit, but then they can break fairly easily. So you don't want to use them for any kind of functional testing. So that's SLA. Next up, this is the Z-Corp process. This is what we call 3D printing. And the advantage of the Z-Corp process is a few things. One, it's by far the fastest technology on the market. It's the lowest material price, and it's the only one that does 24-bit color. So you see this camouflage pattern printed on the model. That's exactly how it came out of the machine. Now, the way the Z-Corp process works is it spreads a powder. It's a plaster composite powder, and then it jets colored binders or glues and bonds it together. And that's how you get the 3D color in it. So it's 24-bit color. You can do texture maps. You can do logos. You can do analysis like FEA or mold flow or CFD analysis and 3D print it right into the model. Z-Corp models are great for concept, design iteration, ergonomics, those types of things, because it's the fastest. It's definitely the most affordable process on the market. And when you get into large parts, it really becomes very price effective. Here's the same Z-Corp technology with a chrome plated part. So they can be painted, they can be sanded, they can be chrome plated. So you can get a pretty decent part. So not quite as good as SLA, but as far as bang for the buck, definitely a good choice for most people. Next up is SLS. This is a selective laser sintering. And how this process works is it's a laser that sinters a nylon powder. This is probably the strongest materials available on the market. Now, these machines are very expensive. The process is very complex, so the parts tend to be more expensive. But what you end up with is a very durable part that has a lot of bend to it, but will go back and retain its shape. So this is the standard nylon material here. They have a glass-filled version here, which is more rigid but even stronger, can have very good heat deflection capabilities. They also have a flexible material here, so it's more like a rubber material. And here's a few more samples of the SLS. This is a living hinge, so you can see not only does that hinge flex, but it's got some snap fits on it. And I can snap that into place, open it up, snap it, and do this over and over and over. So very good repeatability, very good strength and flex. Here's a test strip that shows one of the materials, so you can see I can twist and bend this, and it'll go back to its shape. So if you need ultimate in functional testing, SLS is the way to go, but not good for concept or appearance just because of its price. Now moving on, we've got the objet technology. This is another 3D printing technology that prints or jets a UV curable resin through a print head and then cures it. Has pretty good surface finish like SLA, can do some pretty thin layers. Depending on the part, it can be more expensive than SLA or about the same price. It will really vary. Not as good under heat. They tend to warp with heat, so you got to be careful. But a good surface finish. The other advantage of the objet material is they have a machine that does dual materials. So we can have a hard plastic, and then we could have rubber buttons on here, all built into the same part. So they have a dual material, and there's different durometers you can dial in. So it's very nice if you want to simulate like overmolding or some rubber buttons all within the same part. Okay. They also have a material called Tango, which is also a rubber-like material, and there's different durometers, so you can make rubber-like parts. So that's the objet technology. Good surface finish, similar to SLA, and that's called objet. Moving on, we have the what's called FDM, or fused deposition modeling. This is done with a machine called Stratasys. It's been around on the market for quite some time. Basically, how this technology works is it's kind of like a computer-controlled glue gun. And what it does is it extrudes a plastic through a nozzle. Layer thickness is 7 to 10 thousandths, so it's not as good as some of the others, but it has good functionality because in this case it's ABS plastic. They also offer what's called ABS Plus and polycarbonate. So you can get into some good strength, but you give up surface finish. Tends to be a little cheaper than SLS, so if surface finish is not as important, you may get away with the FDM technology. This one here is a new technology from Z Corp. This is from a machine called the Z Builder Ultra, and this actually uses DLP technology, basically like a high-resolution DLP camera, like a movie projector camera. And what it does is it projects the entire section of the model in a photocurable resin and cures it all at one time. So unlike SLA, where you have a single laser point that has to move around, with DLP they can do the whole layer at one time. Now, the advantage to this technology is it's as good, if not better, than SLA as far as quality and detail, but it's faster because you're doing the whole layer at one time. So this is a new technology from Z Corp. It's very good for surface finish detail, has pretty good strength characteristics, better than SLA, and a good price. So if you're looking for appearance model or high-quality surface finish, this is a great new technology on the market. Now, if you want to get into some low-volume plastic parts, we can get into urethane plastic parts, and we do that by making a master pattern with one of these technologies. Typically Z Corp or SLA or Objet are going to be, or the new Z Builder are the best fit for that. You make a master pattern, and then you make a silicone mold. You basically cast that part in that silicone. You cut it open, and then you can pour in urethane plastics of different colors and durometers. And this is going to get you the closest thing to injection molded plastic, and it's great for low volume, let's say less than 100 parts, without having to go to hard tooling or try to run 100 SLA parts would just be so expensive. Over here we have a metal sintered part, and this is done through laser metal sintering, or what's called direct metal laser sintering, and this is available in cobalt, stainless, titanium, and other materials. Very neat process, fully dense metals, very expensive to do, and it's mainly being used for things like custom medical implants, things like that. But you can see by this shape, you can make very complex shapes in a fully dense metal model. Final thing I'm going to show here, and this isn't a process we offer, but I wanted to at least show it. This is LOM, or laminate object modeling or manufacturing. And this basically uses layers of like a mylar plastic that get glued together, and then a knife cuts out the shape of the part. So the actual part is this piece and this piece here. This is all waste. There's some new machines on the market in this technology that are very low price, but the materials are very expensive. The results aren't very good. You can't do very complicated parts, but I want to at least show this, and this is again called the LOM process. So there you have it. In a nutshell, here are all the different technologies. Now there's many more materials, but these are the major rapid prototype technologies. We want to at least give you a brief overview. Give us a call and send us your CAD model, and we can go into detail on what your application is and what you need, and recommend the right process for you.